this is only my second time giving this talk, and I don't usually give these kinds of talks. So I'm not sure how it's gonna go, but but that's kind of the the conversation I wanted to have, and I hope it turns out okay. Okay, so the reason one of the things I was thinking about is that Ruha Benjamin, so at ICLR International Conference on Learning Representations in 2020, Ruha Benjamin gave this talk that says computational depth without historic or sociological depth is superficial learning. And she also moved on, and she said in this there was this conversation like on the radio between her and Meredith Whitaker from AI Now. Sorry, this was just a kind of her expanding on what she said. So an ahistoric, asocial approach to deep learning can capture and contain, can harm people. A historically and sociologically grounded approach can open up possibilities. It can create new settings, it can encode new values, and build on critical intellectual traditions that have continually developed insights and strategies grounded in justice. So she said, my hope is we all find ways to build on that tradition. And then later on, I was like listening to this, just randomly driving and listening to a radio station, and there was another conversation between Ruha and Meredith where Ruha said, we have so many coding camps for people because we say, everybody needs to be coding literate, math literate, etc. But we don't have any like social science boot camps for computer scientists, for example. Right, so, and I'm involved in one such coding camp, for example. My friend Jelani Nelson started a coding camp called Discoder, and it's a 1-month algorithms class for high school students. It's free, and so I was like, I'm also involved in having this coding camp for high school students because I think it's super important. And but she's right. Like we don't have any of these social science boot camps for computer scientists because we don't think of them as equally as important. So what I wanted to do was talk about why I think this is the case and how it's manifested itself in my life. And so I just wanted to start with like a little just story about myself, just an introduction about myself. So I grew up in Ethiopia, and I grew up really enjoying math and physics, and so I really enjoyed them. And many times I enjoyed them because I also felt control over the classes when I was learning these subjects. I learned about them as completely disjoint from whatever else is going on in the world. So let's say you have political instability or anything like that. I just kind of completely, I didn't connect these subjects to any of those things going on. So as growing up, I am of Eritrean descent. Eritrea is a country to the north of Ethiopia. And I had to basically leave the country, and eventually got political asylum in the U.S. But when I was leaving the country, I left the country at 15. Many times when other things like I felt like I didn't have control over my destiny. I didn't know what was going to happen, and kind of focusing on some of these subjects that I thought were like just completely disjoint from all of that instability, all of those things going on, kind of made me feel that I was having a little bit more control over my life. I also like dancing a lot, and I'm unfortunately can't social dance now. And the first time that I remember sort of trying to connect why any of these different things that I'm interested in, like music, dance, and maybe like math or physics, was that I understand. Sometimes I felt like I learned dance better than some of these things, and recently, I saw a blog post by Rachel Thomas, and so Rachel Thomas was saying, Paul Lockhart, a Columbia math PhD, former Brown professor, left his post as a professor and became a K-12 math teacher because he was just saying that our paradigm for teaching people math is completely wrong. So one of the things he was saying was that when you think about a world where kids are just not allowed to sing at all until they go to conservatories. They know all the notation. They're just like experts in many aspects of music. That would be a terrible world, right? But he was saying he thinks this is sort of how we teach math, is that you don't really get to see and interact with the big picture until you know all of the little details first. And that was sort of my education at Stanford too, like I remember taking electrical engineering EE 101, and we were just learning about convolutions. We were convolving all sorts of functions before I even knew why I should care about convolutions. Like, what's the big picture, right? And so I think this paradigm exists in many parts of these related fields. So going back, I always thought of any any form of social change as different and completely separate from math, physics, engineering, or any related field, because I was taught to think that way. So like I worked at Apple for 6 years, and I worked on like ADV converters, for example, analog to digital converters. I was just interested in the mechanics. To the left is also another attempt of me trying to connect my two interests of music and analog circuit design. I feel like that's how I got my first Apple internship in the audio team. So I was trying to create like a single piano key. This was a class I took. It was an undergrad class I took at Stanford, like EE 121 or whatever. And then to the right is like, all of these, I don't know, all of these oscilloscopes and spectrometers and all these things connected to some board. It was an A to D analog to digital converter. And I was super interested. For some reason, I was really interested in these things called delta sigma converters and analogs in A to D conversion. I was just very interested by the mechanics of it, and I only later learned when I was learning about these things about their connection to World War II, radar decoding, and why all of these paradigms became very popular, and how they were funded and how they arose, basically. So along those lines, I also didn't learn about, I learned a lot about, transistors. Obviously at Stanford, like I heard William Shockley's name all the time in connection to the transistor, and the invention, the fact that he got the Nobel Prize, et cetera, but I never learned about his connection to eugenics, right? So, for example, here is some of like the things he said. There's a lot here. There's about how the view that the U.S. Negro is inherently less intelligent than the U.S. white comes from my concern for the welfare of humanity, et cetera, et cetera. And so I also never learned about how tech institutions and labs, including all of the institutions I'm connected to, Stanford, whatever, Google, Silicon Valley as a whole, et cetera, made their money. Again, like I said, the only thing I was, as a good engineer, as a good student of these fields, you were not, you're supposed to think of everything as super objective, completely different from power dynamics or, political dynamics in the world, and just kind of, work on quote unquote something that's technical, right? So here is there's this for example this article that just very recently came out about students were protesting Henry Kissinger's presence at MIT when they were starting some ethics related institute. I forgot exactly what its name was. And so this article is saying that in the same way that MIT and other institutions are now working to explicitly acknowledge their histories with slavery in the U.S., they should also work to explicitly acknowledge their contributions to human suffering and international conflict. So, AKA war, right? And so, like I said, I know even though my family and I have been extremely affected by war, war has been the single thing that has affected our lives the most. I still, my dad was an electrical engineer. My two sisters are electrical engineers, and I studied EE as well. And I never kind of was taught to connect any of these things to each other. Are you guys with me? Is this the kind of keynote? Okay. All right. Well, I really wanted to have this conversation because, not just in the U.S. but around the world, we're in this moment where, I'm in California, and it was so strange. One day we had this orange air, like the air was just orange. It's 10 a.m. and it's orange air. And instead of being like, stop everything, the world is about to end, we need to figure this out, I was like, I woke up, I saw this orange air, terrible smoke. Well, I guess I gotta check my email, I gotta do my work, just go about my business. And that just feels really strange to me. kind of just going about my business in the current life that we're in today. Anyways, to continue, so like I said, I didn't learn about how tech companies affect the world, labor unions and labor movements. So like if you think about the AT&T or Bell Labs or any of these prior companies. My sister used to work at Bell Labs. And the Ford, the automotive companies like Ford, there's a huge history of labor unions there. And so, for example, at Stanford, when I was going about my business, learning about as an undergrad, the one thing I learned, all of these stories, all these things that I learned about, were that Stanford was very proud of its role in starting Silicon Valley, and that Stanford encouraged that startup culture. So we had all these stories, for example, how Terman, who was a professor at Stanford, lent Hewitt and Packard money when they needed it, or something like that, and that how he helped found the Hewitt Packard, and how that kind of jump-started the whole Silicon Valley revolution. There was so many of these stories, but none of the stories about how tech companies are affecting the world and how their connection to I don't know, the war, politics, any of that stuff. So what I just sort of described, this view that technology is, we're supposed to see it as something neutral. We're supposed to see science as something objective truth. From not necessarily from someone's point of view, not from my point of view or somebody else's point of view, and not something that's affected by how I was raised or where I was raised or my view about the world, is called a view from nowhere. So a lot of queer feminist critics, especially the scholars, have written about this critique of science, of the way we conduct science, and the critique, they call it the view from nowhere. So it's the assumption that the point of view of the person does not really affect the outcome of the work. And I think this view pervades a lot of what we do, and I find it to be at the root of many of the issues that we try to talk about in terms of fairness, accountability, transparency, etc. And so here's an example. This is a good conversation with Sabelo Mhlambi, on he talks about this is a great interview if you have the opportunity to look at it. Read it. He talks about, for example, what AI can learn from Ubuntu ethics. And so, if you really look at the root of like some of the ways in which what types of paradigms, what types of values are pervade in AI, you can, really trace it to the difference in values, like Descartes versus, other kind of understandings of the self. Actually, Ababa Berhana also writes about this, which is interesting. So here's an example where he says, by the way, I think it's worth mentioning that Leibniz was building on ideas from Raymond Lull, a 13th century Frenchman, who thought he could derive a symbolic language that would let him build a logic machine that would convert Muslims to Christianity through reason. So like I said, our values, the values of the scientists or the engineers or whoever, are always kind of pervading what we're working on. There's a recent paper I read called, I think the implicit values embedded in healthcare inequity measurements or something like that. It was a great paper because it talked about how just your choice of metrics, your choice of what you choose to compare, whether it's absolute versus relative values, ratios versus differences, subtractions, etc., what kind of choice of geographic unit, what kind of values that encodes. So they go through case studies to kind of educate us about that. And then their final kind of answer is, a lot of people ask me, what's fair? How do you measure fairness, etc.? Their final answer is, there's no one metric. It's just the best strategies to understand that you're imbuing your values into the system, and be extremely transparent and thoughtful about which values you're encoding. So throughout my graduate career, so being a good engineer meant decoupling all of these things I was talking about and showing how good I am at something that was quote unquote technical. So caring about society was not really a good thing. You know, it wasn't really seen. And injecting my values or my thoughts into it was not necessarily a good thing. So I tried to get away from that as much as I could when I was in grad school. I have always been part of some sort of social change. I've always had to, many times by necessity. So like I said, I'm of Eritrean descent, and Eritreans had a 30-year struggle for war. Many of my family members were either imprisoned or disappeared or whatever it is, or like died or something like that. So it was always in our life to think about these things. And so even, you know, as a refugee, as someone who had to leave my country when I was 15, coming to the US, seeing what's going on right now, I've always been, you know, I've always had to be by necessity involved in some sort of social change. However, I wanted to be 100% clear about my quote-unquote technical work versus that. And anything that tried to connect those two, I was like, nope, I do not want to be the Black woman, you know, doing Black woman things or talking about Black people. Or I want to first be known for my, you know, computer science technical work, and then, you know, the other thing. And so my advisor at some point, Feifei, was like, you know, you should, you know, have your PhD in a way that connects those two things. You know, you should write your thesis in a way that connects those two parts of yourself, etc. And initially, I actually fought her on that. I was like, no, absolutely not, you know. And so because, like I said, you know, from my entire education and my entire work career, and I think the paradigm that we operate under is that view from nowhere paradigm. So this is kind of what I was talking to you guys about. And so during my PhD, I wanted to make sure I was not seen as a quote-unquote activist. And so now, I don't care now. I mean, I'm just like at this point. But you know, a lot of people describe me as that. And so it's not a problem, right? I don't have any issues with being an activist. I think it's important to have activism, especially by necessity. But sometimes it's done in a way that separates you from the scientist. So there's the scientist and there's the activist, right? So this happened to me after I gave a talk at Caltech, and I talked to Pietro Corona. And during a one-on-one, he was telling me that I was weaving in and out of science and activism and during my talk. And like at some point I was talking about, you know, he was like, I was talking about my view of how the world should be versus science. And then I was having this argument with him where I was saying, you know, you're never disconnecting science from your view of how the world should be. We're like going back and forth. And so this thing about being called an activist, El Mahdi, who's a Moroccan researcher, he researches he's a theoretical computer scientist, but he studies robustness and distributed systems. And he actually wrote on Twitter about this idea of how I'm always, you know, called an activist. And he talked about how there's this Carl Sagan effect where, I don't know about this, where, you know, scientists engaging in public dissemination is perceived as less productive than those who are not. And then he was also talking about why it bothered him, that dichotomy between activist scientists, because in Morocco, when they're discussing certain journalists, they would call them activists, and that is to separate them from the journalists, right? You can say, oh, those are activists, those are journalists, so then it becomes easier to persecute the ones that you say are activists rather than journalists. So he was saying that he felt that was the way in which I was many times when I was called an activist. It was not in a very flattering way. But then on the other hand, I think right now a lot of people, I hear a lot of talk about interdisciplinarity and how it's good, right? There's interdisciplinary initiatives. There's interdisciplinary, like bringing ideas from other topics is considered a good thing. So machine learning, there's all these physics-based models. There's all this research into physics-based models. There's ideas from game theory that have made it. So for example, generative adversarial networks have a lot of ideas from game theory. So then my question is, you know, why not ideas from history? Why not ideas from critical race theory? Why not ideas from anthropology? Why are those not as celebrated as all the other ideas that we bring into the field? And I think a lot of it has to do with the hierarchy of knowledge I mentioned at the beginning, where Ruha was saying, you know, we inherently assume certain types of knowledge are better than other types of knowledge. For example, like her comment about coding camps. I also think there's always gatekeeping between people who have power and people who don't have power, and this happens all the time. So I remember someone told me that MIT doesn't have a stats department because the mathematicians just thought the statisticians were not hardcore enough, and so you cannot have a stats department. But we always have this conversation, and you feel like, what is real computer science? What is real computer vision? What is real machine learning? Who is doing real X? And that conversation, I feel, it's always a mechanism, a gatekeeping mechanism, and that keeps the hierarchy of knowledge. So here is an example where Mar Hicks, who is a historian, a tech historian, and I follow Mar Hicks' work a lot. I learn a lot from them. And this book called Programmed Inequality talks about the history of computing in Britain and how women, I think at this point, a lot of people know that women were the first, computers, right? The human computers, and it was considered to be like a woman's job to be a computer and a programmer. And even when people were, when you saw ads for these jobs and stuff like that, they tried to make it quote unquote feminine, like pink and all this, like it was considered a woman's job. But then during the advent of the personal computing, when this technology started to have more power, right, more market share, it was more profitable, the women were basically pushed out, and it became now a man thing to do, right? And this happens many times. So this type of gatekeeping is always done by those who have power to gatekeep the people who don't have power. So there are examples of people trying to undo the effects of this type of gatekeeping. So one is decolonizing history, because history is always told by specific perspectives. And so this is done, so for example, people in South Africa have decolonizing history initiatives. That means, what type of knowledge do you respect? Oral histories, certain kinds of modes of communication like music, art, there are like stories that are encoded in them, versus only kind of assuming that written text is the thing you should study. That's one example, art. And so most recently in my work, I've been trying to bring ideas that are mostly based out of my discipline, my current discipline, to my current ideas that are based outside of my current discipline to my current discipline. So I just wanted to give a few examples of that. So this one is called data sheets for data sets. And so this idea came from my days as a hardware engineer. And so I saw that, we wrote this paper, data sheets for data sets. Basically, the idea is that in electronics, every single component is accompanied by a data sheet, right? So you have, like if I wanted to see whether this component is appropriate for my system, I would first go to the data sheet. I would see its the characteristics, what kinds of stress testing has been done, what kind of characteristics it has, and what kind of non-idealities it has, etc. So it gives me information about the component so that I can make informed decisions about whether I should use it somewhere or not. So the idea was to have that similar idea for data sets. So right now we just release data sets, and people don't really have information about the distribution of the data sets or a bunch of other information, and that allows them to make informed decisions about where they can and cannot use it from. Where they can and cannot use it. So this is one idea. Along those lines, we also worked on this paper called Model Cars for Model Reporting. It's a similar idea for models, right? You release trained machine learning models into the wild, into the world, with not much stress testing at all, right? There's this train test paradigm where you have a single accuracy metric, but the testing, the rigor in testing in this space is very different from what I'm used to in, like, let's say the hardware paradigm. And so that was this is the idea that we had, and so that's one example. Another example was from history. So I worked with historian Unsojo. So the talk I was planning on giving was actually going to be about this one, but I thought maybe it was better to start with this overview. So this was about data collection methodologies, and how we can learn from archival historians, because archives are the oldest discipline that has been collecting human-related data. So there are so many issues related to data collection. So what are the lessons that we can learn from archivists? So this was a collaboration with Unsojo, who is a historian at Stanford University. And a lot of this was about process. So same with data sheets and model cards. It's not math, right? It's not an algorithm. It's about process. So how do we have better testing, documentation, collection, processes to create a foundation to sort of change the paradigm that we're under right now. So this is kind of a summary of some of the things that basically to show how much resources and time people in archives spend on data collection and annotation, as contrasted to those of us in machine learning, computer vision, et cetera, data science, whatever, where we do not spend nearly as much time and resources as they do. So then this other, there's this understanding of the racial construct and the gender construct. So some ideas from critical race theory. I would say this is the most influential work I have been a part of so far. So this work was led by Joy Buolamwini, and she'd been working on this since 2015. And so she noticed that she was just doing some random art project, and she noticed she was trying to use open source face detection software. And she noticed that the open source face detection, so from software from OpenCV or something, wouldn't detect her face. It would detect her roommate's face, and it would detect her face if she puts on a white mask, but it wouldn't detect her face on its own. So we decided to do a systematic study of some of commercially available automated facial analysis APIs. And so this is an excerpt of her, a paper that we published based on her MIT master's thesis. And so in this excerpt, we measure the disparities and error rates of gender recognition systems. So what these systems do is they look at a picture of a face, and they tell you whether it is a man or a woman. So it's a binary label. There's no differentiation between sex labels and gender labels. There is no kind of understanding that gender is maybe a social construct, and that it's not stable across time, space, cultures, etc. So what we did was we said, okay, let us do a systematic analysis, and let's have a data set that is more balanced by skin type and gender. We used skin type because we know that race, again, is a social construct that doesn't really have any sort of objective meaning. Somebody's race in Brazil is completely different. Can be different from the US, can be different from South Africa, can be different in the 19th century versus the 21st century. It doesn't really tell us much except for the social construct that it is. So we said, let's use skin type. So we used this Fitzpatrick skin type classification system to just look at whether, how dark someone is, how that affects the results. And we also annotated gender. So we had this data set of parliamentarians. So we found that they're darker and darker in skin type. For women, some of these even approach random chance, right? If you flipped a coin, your error rate, and you guess, your error rate will be 50%. So this work resulted in many things. I mean, right now there are basically many bans across the U.S. On face surveillance, use of face surveillance by police. There's a lot that happened, I would say, based on this work. Another work where we are bringing ideas from other places is this paper on diversity and inclusion metrics. So what we're looking at here is, let's say you have image search. Let's say you have you're trying to select a subset from a larger set. So let's say you have a query for something, and then you have image search, and you want to have a result that's diverse and inclusive. What does that mean? How do you even measure whether something is diverse and inclusive, especially inclusivity, which is such a personal, social construct, right? And so in this work, we brought This is work with like people who have a background in econ, organizational social science, and like linguists, computer vision researchers, theoretical computer scientists, etc. So I just wanted to give like a little bit of an overview of like the kinds of the ideas that were brought from other disciplines. They weren't necessarily math. They weren't necessarily sometimes they were like, so in this work we had some math from social choice theory that was helpful. But in many of the other works, especially I would say the most effective ones, it wasn't because I brought some algorithmic component from one field to another. The papers that were effective, I would say, there were a number of reasons for it. The first one was focusing on a foundation. So like I said, process and basic, what are the things that we need to do to make an impact before figuring out the declarations. So sometimes there's a lot of works that talk about, what is it? There are like 30-something definitions of fairness, let's say, right? And so I would say that's like a declaration, in my opinion. There's foundational pieces that are missing in terms of documentation, in terms of auditing processes, etc. So that's the first thing I would say I try to do with my colleagues. The second one is focusing on impact. And the one example of that is we wrote this paper, Model Cars for Model Reporting, but we're still working on this 2 years later, or we're still working on it. And it's not like we were done after the paper. We are like trying to actually operationalize it. And especially Meg Mitchell, my co-lead of Ethical AI team, and some Parker Barnes worked really hard to have this pilot. And we have to guide people to see like how this could be useful. So we just didn't stop at the paper, right? The other one is domain expertise context, and actually contrary to the view from nowhere, bringing in my lived experience and the understanding that I have based on that. So an example of that is the work with Joy, where we kind of had our own lived experiences of, colorism, even within the racial construct, understanding the gender construct, etc. Another one is collective movements. So here is an example where Deborah Raji had a follow-up paper with Joy Bulamini that showed that Amazon's recognition tool that they sell to police, were selling to police, they have now a moratorium in to law enforcement, showed similar biases, could have similar biases to the ones that Joy and I showed in our paper, Gender Shades. This paper came out, so this is a New York Times article. This paper came out, VP after VP was attacking Joy and Deb. And so what they were trying to do was attack the technical piece of the work. And they were super scared. I mean, Deb was an undergrad at the time. So you have a VP hiring a PR firm trying to attack an undergrad. So when this happens, this work is impactful because they're super scared about the potential results, right? And so Deb told me that before she came to this group, Black and AI, which I co-founded with my colleague Reddy Bebe, she would have dropped out of the whole field because she felt a lot of isolation, discrimination. She was alone, and many things that she faced. But when she came to this group, she found support, and so she was able to stay on and work on this work. In addition, once she started getting attacked, besides that, sorry, I was going to say, Joy Bulamini, who's the first author of the Gender Shades work, has this, so my colleague Reddy Bebe and I founded Black and AI. Joy has the Algorithmic Justice League, which is at the forefront of many of these bans that you see in terms of face surveillance, etc. So Joy and Deb, these two people, wrote this work, Actionable Auditing, and like I said, VP after VP kind of came after them. Me and my co-lead Meg Mitchell wrote this rebuttal. So I had to hold my tongue on Twitter or whatever, I can't say anything. We spent 1 month crafting a rebuttal of this to everything that the VP said. We spent 1 month writing it, and then we asked for help from our colleagues from the computer vision community primarily, and also some people like who are famous, like Yoshua Benjo, who had just won the Turing Award, his brother Sammy Benjo, who's our manager. So once we wrote this, basically when Sammy was like, hey, I I might get fired for this, but hey, you know, we have to do this. Like, we can't just let people kind of get away with this, and this is super important to our community. So we, after we wrote this letter, Anima Anand Kumar was one who was formerly at Amazon, at AWS. So we wrote this letter, and we wanted to make sure it didn't become like an Amazon versus Google thing or whatever, right? This is from the community. So we wrote it, we made it anonymous, and we asked signatories. So we had an anonymous letter, and then we had a number of signatories. And so that protected a lot of people who wrote this letter. And so once we had the signatories, there was a lot of press about it, and it was very difficult for Amazon to then continue to attack these women because we had a point-by-point rebuttal for this letter. You can find the letter online if you're interested. So again, collective movements. Art was also very helpful in making this work effective. And one of the people who's one of the most effective researchers I've ever worked with is Joy, because she didn't just write a paper, like I said, she just acted on, you know, she had collective movements, she had art, etc. So here is a documentary called Coded Bias that if you're interested in this topic, that you can watch. About face surveillance and a lot of Joy's work, and Joy also had spoken word, and she was she was a headliner at something like this concert called Afro Punk, and spoken word about this work. So these are all different modes of communication, right? Art, spoken word, collective movements, etc. This work so a number of people in Black AI have been working on decolonial AI, what they call decolonial AI. And so here's, and now they have a collective, and so there's lots of, you know, pieces of poetry, art, blog posts, etc. And so many people have also put out papers on decolonial AI. So Alawa Berhane has a paper about algorithmic colonialization of Africa. Marie-Tracy Shakir and William have a paper called Decolonial AI, and they talk about some of these things I touched on, for example, like different modes of communication, different languages of communication, and how they're seen. So, of course, everything I have said, I believe probably has been said by somebody before me, and the one person that I'm pretty sure has said most of this is Carrie Wagstaff. I found this paper. I believe my colleague, Jumwon Vaughn, was the person who told me about it. And so I think this was a keynote at ICML in 2012, and I heard it wasn't that very well received, but I don't know. So what Carrie says is that, you know, there are all of these things that are necessary to make research impactful. Machine learning based research impactful. You have to phrase a problem about as a machine learning task, collect data, select or generate features, choose or develop an algorithm, choose metrics, interpret results, publicize results, persuade users to adopt technique. For some reason, though, in our conferences, in our schools, in our paradigms, we only talk about choose or develop an algorithm, choose metrics, and conduct experiments. Those are the things that are considered valuable. And so this is what I mean by the hierarchy of knowledge. And so I would say this is because of the hierarchy of knowledge. Even though all of these things are really important to make research impactful, we're over-focused on this middle aspect. And another person who sort of said similar things is Philip Rogway, is a cryptographer. He wrote this paper, it's like 40 pages or so, in 2015 called The Moral Character of Cryptographic Work. And so Philip Rogway talks about how the cryptographic community, he sees the fact that mass surveillance has not been stopped as a failure of the cryptographic community. And so he first talks about how physicists were active in nuclear disarmament. He talks about a number of things. He goes through some history. And then he analyzes different cryptographic, algorithms that have been proposed, like, you know, differential privacy, for example, or various other algorithms. And he talks about the effect of abstraction. So what he's saying is, in cryptography, we usually have so much abstraction. Like you say, you know, Alice and Bob are trying to communicate, and here's the adversary, and then, like, here's the algorithm, you know? And so what he's saying is, you have to really think critically about who Alice is, who Bob is, who the adversary is usually in real life, what kind of resources they have, what kind of dynamics they're in. Otherwise, this too much abstraction might lead to the development of algorithms that don't really help in the real world. So like he goes through a number of examples there. So like I said, a lot of people have been like, I was told, but what did she really do in computer vision? What was the algorithmic component of her work? And so my question is, why does that have to be the pinnacle? Why is the pinnacle, like I said, that middle component of all the things we need to do in research? And my answer today, I think, is, again, like I said, the hierarchy of work. So Mary Gray, who's an anthropologist, has written this book called Ghost Work. So this book talks about how Silicon Valley is basically, or not just Silicon Valley, I mean, the whole world of machine learning, the automation, is powered by ghost work. And that this ghost work comes from a lot of data annotators who are not really paid nearly, as much, because if they were paid a living wage, then it suddenly, like, it would take a lot more money to collect data and perform these automations, right? And so what she's saying is some of our attitude in terms of the hierarchy of work, for example, is creating a second-class citizenship around the world. So I highly recommend if anybody has time to read this book. I'm almost done, by the way. I'm sorry, I haven't been able to see time, but am I okay? I have like a few minutes, but that's
you still have a few minutes, yeah.
Okay, good. I'm almost done in a few minutes. And so this lack of respect for data-related labor, I think is at the root of many of our issues. So, for example, we're not careful in the way we gather data, because I don't know how it is here, but in computer vision and machine learning, etc., try to submit a data set related paper. Data sets take 3 years to collect, but versus the thing you're doing on the data set maybe the 6 months or whatever. Your 3 years to collect is probably 2 pages on a paper. And if you want to write a whole data set paper, it's so hard to get them accepted, right? It's like, oh, but what was the algorithmic component? Oh, but this is just a data set paper, just a data set paper. So I'm heartened that actually now I think a few people are trying to change this. I know that Isabelle Guyon said that she's, for example, at NeurIPS, she's trying to have a data set and benchmarks track. And then I know Neil Lawrence is saying that he's trying to have a data journal. So I think that this is a very good first step, is to encourage people to think very critically about data and encourage people to take their time when they're working on data. So these issues with data sets used in computer vision have been uncovered by many people. So Vinay Uday and Vinay Prabhu and Ababa Berhana, for example, just wrote a paper about large-scale computer vision data sets, and I believe that Antonio Torralba and Rob Fergus and Bill Freeman took down Tiny Images data set after seeing this paper. Emily Denton, Alex Tanner on our team, and Morgan Klaus are working on a long-term research project called the Genealogies of Data. So trying to understand how the fields, practices, and values are imbued in different data annotation collection practices. So Emily Denton and our team has the talk at NeurIPS on some of the issues related to generative modeling, and especially the data sets used in it, like Celeb A, etc. So if you're interested in these works. Some of these issues that I'm talking about manifest themselves even in this space of fairness, accountability, transparency, and ethics. So because we don't respect a lot of different kinds of work, there's a lot of algorithmic fixes or techno fixes that I believe are, in my opinion, sort of decorations, like I said, before building a foundation. Or sometimes they actually make things worse. So make fair face recognition, without thinking about whether where face recognition is okay versus not. And to start with, parachute science is something that people describe where people in one group are studying people in another group, or they want to save them. So they're doing research on people in this group, and they come in and they take the knowledge that this group has, and this group is the one publishing on it and benefiting from it rather than this group. So that's the hierarchy of knowledge, right? That you're not seeing this group as your collaborators, you're just seeing them as your subject of study. Recent examples of race science, there's been a number of papers that have been pulled down from like high-profile journals because people wrote letters, they were outraged, and that's because there was this revival of race science that has been debunked, many years ago. And again, I would say this is because the studies like race and gender studies in the hierarchy of knowledge in our field are not very high. And there's entire computer science communities exploiting people at the margins for working on fairness. I find it very strange where if you're working on things related to fairness, let's say, and you're completely excluding the knowledge of the people who are so intimately aware of what unfairness is like, and then you're going off and having your conferences and publications. That's, again, like I said, the reason for me is because those people at the margins, their experiences, their lived experience is at the low hierarchy of knowledge. And then you have ethics boards. So now I think a lot of people in tech are having the memo, they're getting the kind of the point that you need to have ethics boards and reviews and principles, AI principles and all that. But like I said, if these ethics boards don't include people at the margins who have the lived experience of many of the negative impacts of the technology that these ethics boards are supposed to prevent from going out, then they're not going to be useful. So here are examples of articles that talk about some of these phenomena. So then I was asked by Pietro, what about curiosity-based research? So then the question is, whose curiosity-based research is funded and whose voice is amplified when we're in this, hierarchy of knowledge. So this imbalance can create harmful curiosity-based research. So one example is I talked about gender recognition earlier. But a lot of people in the trans community especially have written about just the task of gender recognition itself can be harmful to people in the trans community. If that knowledge was from the very beginning considered high, the hierarchy of knowledge, right, I think that this research would have taken maybe a very different turn. And so I think what I wanted to close by is basically saying that this assumption that people's position in society is not affecting their research, whether curiosity-driven or otherwise, is something that we should really try to move away from. And this hierarchy of knowledge, like I mentioned, we have a hierarchy of knowledge, and it's usually a result of power structures. And I think that it's at the root of many issues that we're trying to study right now. And it's, in my opinion, it's not just an industry versus academia issue. It starts from the paradigm of what science is and how it's taught. And I really think it's important to kind of start to have various institutional incentives to change how these disciplines are taught and change what's valued. And I think it affects all forms of research, what questions are considered important from the inception of the research, what is the meaning of rigor, what does it mean for something to work well versus not, and what does it mean for something to be good science. And so I wanted to close by like showing some of the lists of books I had, when I was an undergrad. It was like, a lot about delta sigma converters, Oppenheim-Schaefer, just like signal processing, electromagnetics, CMOS design, etc. And then right now I'm really trying to catch up with like all the other education I just didn't have. And so this is the stack I'm working through. So sorting things out is like it's a book that was recommended to me by a social scientist in our team, Alex Hanna. It's about like how science, how just the need for classifying categorization in science, what kind of effects it has. I haven't read it yet. Ruined by Design was suggested by Ruha Benjamin. Black Software, Statistics, Algorithms of Oppression is by Safiya Noble. Captivating Technology, Race After Technology, which I highly recommend, by Ruha Benjamin. Haben is a deafblind scholar, a disability rights scholar, and this is her memoir. Dark Matters by Simone Brown is about the history of surveillance and technology and their relationships in surveilling marginalized groups. And Artificial Unintelligence by Meredith Broussard. So with that, I'd like to thank people in the Ethical AI team who I've discussed this a lot with, especially Emily Denton. And thank you for having me and for listening to my last, my keynote that I decided to give.